Here's an example of a common geometry problem that deals with semicircles, squares, and finding the area bounded by the two semicircles. A square with side lengths of r is intersected by two semicircles with a radius of half of the side length of the square, such that the center of the semicircle is on the midpoint of the sides of the squares. What is the area of the shaded region? This will be a general example followed by a specific example. This problem, you should first put a square. So the intersection of the two semicircles is at the center of the larger square. We want to find out the sector area, area 1, which is the side length of half the side length of the square. That's r over 2. The formula is provided in the slide. Next, we want to find the area of the triangle, area 2, which has the same base as the radius of the semicircle. The formula for calculating this is below the image. Once area 1 and area 2 are calculated, we simply need to find the difference of the area. The graphic helps show how the composite areas fit together. This is good for somebody understanding exactly how the algebra of the formulas work. Once we found the difference between areas 1 and 2 and called it area 3, now we can simply double area 3 and we'll be able to find the actual shape of the area of the shape that we were looking for. So to review this problem, area 1 was a sector. It's like a quarter circle with the radius r over 2, r being the side lengths of the bigger square. Area 2 was a equal isosceles right triangle. Area 3 was the segment when you take the triangle away from the sector. And area 4, we doubled the area of the segment. This general formula will help us solve all the other types of problems like this. Sample problem. A square with a side length r, which is 10 centimeters, is intersected by two semicircles with a radius of r over 2, such that the center of each semicircle is on the midpoint of the sides of the square. What is the area of the shaded region? We find the first area by taking half the area of half the length of one of the sides of the squares. We apply it to the arc formula. We end up with 25 pi over 4. Area 2 is that isosceles right triangle that's created, and it has a base of 10 over 2, which is 5. So 5 squared is 25. And we divide that by 2, and we end up with the triangle formula, we end up with 25 over 2. Next, we subtract area 2 from area 1. That gives us the segment area. And that segment area works out to approximately 7.13. We double that, and we get the area of the shaded region that was supposed to be found in the original problem solver example.